Understanding time is the key to understanding quantum physics. In quantum atom theory, the individual atoms are creating their own space-time geometry by the emission and absorption of electromagnetic radiation. Because it is impossible to achieve absolute zero, everything is radiating electromagnetic radiation continuously, creating the forward momentum of time. When there is a photon-electron coupling, two-dimensional space on the surface of an atom expands into three-dimensional space-time. Even the individual atoms of the observer are creating their own space-time geometry relative to their position and momentum. In this theory, the wave function represents the time continuum at the most fundamental level. Time only moves forward because the probability of the wave function only works one way. We always know the position and momentum of a quantum particle in the past. The uncertainty principle of quantum physics is the same uncertainty that the observer will have with any future event. Therefore, there is no universal time, and everything is relative. Because the individual atoms are creating their own space-time geometry, therefore the observer is the only true reference frame, and we have relativity. If we look up at the stars, we can see back in time through light years of space. The farther we look, the further we see back in time. The position of the observer within the universe makes no difference. Whatever planet or galaxy he observes from, he will see the universe expanding and be able to look back in time in all directions. This process of looking back in time can be put in reverse, and the closer we look at an object, the less time will elapse. The light from the sun takes just over 8 minutes to reach us. The moonlight takes 1.28 seconds, and the light from everyday objects must take only a fraction of a second. There must be a limit to how high we can magnify an object and still have a process of time. When we look down into an atom, we can only see the probability of the uncertainty principle. This is because the process of time is created by photon-electron couplings that expand as a quantum wave particle function, as an inverse volume of space, in the form of a light sphere of quantized wave fronts, creating the forward momentum of time. Time is inverse, just like multiplication and division. When an atom emits a photon or quantum of energy, we have multiplication, and when another atom absorbs that quantum of energy, we have division. Therefore, time has a strange property for the observer of always moving on, but the observer remains in the moment of now. In quantum atom theory, at the quantum level of the atoms, the moment of now is created by a single photon-electron coupling, creating a wave function of future possibilities. On the level of everyday objects, the observer will see the multiplication of photon-electron couplings, creating a temporary image of the universe, moment by moment. We therefore have a sea of electromagnetic radiation, creating a blank canvas for the observer that he or she can participate in. This is what Socrates called a sea of beauty. The only way to see this happen directly with light is in the two-slit experiment. When the light reaches the screen with the two slits, the photon will react with the electrons of the screen, collapsing the wave-particle duality of the light into new quantum particles in space and time. The part of the wave that does not come in contact with the screen will go through both slits as two light spheres of quantized wavefronts. There will be constructive and destructive interference between the waves. When this wave-particle function comes in contact with the screen, it will collapse, creating moments in time and quantum particles in the shape of an interference pattern. When the observer turns on a detector to determine which slit the photon passes through, the interference pattern will collapse. This is because to observe the photon, we have to create a photon-electron coupling, collapsing each wavefront into a new quantum particle that will have its own position in space and time. If we turn the detector off, we remove the photon-electron coupling, and in time the interference pattern will reform. Just like in Newton's first law of motion, the interference pattern will continue to maintain its state unless acted upon by an external force. Every object in our universe will create its own space-time geometry by the emission and absorption of electromagnetic radiation, collapsing the wave function into new quantum particles that will have their own position in space and time that the wave function never had before the collapse. Because the observer can choose when and where to collapse the wave function, we have free will to create our own future. If the observer does not collapse the wave function, the quantum particle will only have the momentum of its own wave-particle function. This is very difficult to visualize, but in this oil painting of a geisha girl walking through sunlight, the wave-particle duality of the light will collapse as she walks through the rays of light. She will collapse the wave function into moments of time and space, creating her own space-time. We have entanglement because the polarization will be set at the creation of each expanding wavefront. The wavefront will expand in the form of a light sphere, and the polarization will remain the same for the entire surface of the light sphere, no matter how large it becomes. Because this process is at the same speed of light, the expansion of light between the atoms will always be a universal constant, independent of the motion of the source. This can also explain why light is so beautiful when it strikes an object. It is because we are looking at a moment of pure creation of time and space. When the wave function of the two spheres comes in contact, the wavefronts out of phase will cancel each other out, and the wave in phase will superimpose. The radiating energy will be entirely absorbed proportionally to the masses within the objects. This will cause an unbalanced force, and the two objects will resonate together in a process known as gravity. Because atoms consist mostly of empty space, electromagnetic radiation of short wavelengths, like X-rays, can penetrate the objects, and therefore every single part of matter can take part in the gravitational interaction. We have the inverse square law because the surface area of the light sphere increases with the square of the radius. Thus the strength of the gravitational force is inversely proportional to the square of the distance from the source. Therefore we have a universal dynamically evolving geometry of time in the form of ever-expanding spherical quantized wavefronts. The observer will feel this as the forward momentum of time and will see patterns of a beautiful symmetry, not because of their mathematical position in space, but it is also because of their sequence in time. The atoms will distort the geometry of space-time, creating mathematical patterns of every conceivable shape. The same basic method of pattern formation, the same mechanism of symmetry breaking, governs the whole universe of organic and non-organic matter. Everything will form into ever greater complexity, because everything is creating its own space-time geometry of ever greater diversity. Only a slight distortion in the space-time symmetry will spiral out, creating the visual patterns of our universe. It is easy to see how our infinite sequence of whole numbers can represent the infinity of three-dimensional space, because the numbers can be used to represent three-dimensional shapes. But it is the irrational numbers that drop out of the whole number sequence that represent the never-ending expansion of time. In quantum atom theory, the irrational number pi is a physical constant and represents the expanding curvature of space-time. It is not just because it is random and carries on expanding forever. Its position within the whole number system points towards its link with the forward momentum of time. In quantum physics, it takes three quantum numbers to calculate the wave function as it expands as an inverse volume of space. The decimal expansion of pi starts at the number 3 and goes to infinity, representing three-dimensional space-time. This theory is very simple, but it can explain the paradoxes of quantum mechanics, and we have free will for the creative evolution of our own reality within the dynamically evolving universe of Einstein, and quantum mechanics and classical mechanics of Newton are united.